Hello, night travelers, those restless souls who carry wanderlust in their hearts, yet seek calm within the quiet symphony of the night. Welcome back to the Night Observer, a place where minds come to rest, where sleep arrives gently, and where thoughts are free to drift across the vast and mysterious universe. The fire is lit once more. We gather again in its soft glow, warming our hands, listening to stories whispered by the cosmos. Together, we lift our eyes toward the sky and allow ourselves to dissolve into its immensity. Tonight, we will not speak of modern spacecraft or distant probes. Instead, we will journey inward, back through the history of human thought, to the very beginning of our questions. Tonight, we ask, when did humanity first begin to dream of life beyond Earth? Why does this longing grip us so deeply? And as we search the heavens, are we truly looking for neighbors? Or are we quietly seeking an escape, a path forward for the day our fragile world can no longer hold us? Take a slow, deep breath. Let your heartbeat fall into harmony with the timeless rhythm of the night. And listen now to a story whispered by ancient stars, the origin of a millennium obsession. Seeds of thought beneath the ancient sky. Dear night travelers, our fascination with extraterrestrial life is not a modern invention. It was born alongside human awareness itself. Long before artificial lights dimmed the Milky Way, our ancestors stood beneath skies alive with stars and felt themselves being watched in return. In the West, the philosophers of ancient Greece dared to imagine a universe far larger than their world. Thinkers such as Democritus and Epicurus spoke of countless worlds scattered across infinity. Epicurus reasoned calmly and boldly. If the same natural laws created plants and animals on Earth, why would they not do so elsewhere? To him, an infinite universe confined to a single living world made no sense at all. At the same time, in the East, similar ideas quietly took root. Ancient Jain texts from India described multiple realms, vast lands beyond the visible world, such as Bharat Kshetra and Mahavidya Kshetra, where life could flourish. In this vision, existence was not isolated, but interconnected, and humanity was only one thread woven into an endless cosmic fabric. The wall of certainty and the comfort of being alone. Yet these early visions soon collided with a powerful barrier, one that would stand unchallenged for nearly 15 centuries. Aristotle's geocentric universe placed Earth at the center of all things. In his view, everything naturally fell toward this center, making Earth not just special, but singular. The cosmos was divided neatly in two, the imperfect, ever-changing realm beneath the moon, and the flawless, eternal heavens above, composed of a mysterious substance called ether. In such a universe, Earth was not merely inhabited, it was chosen. Life elsewhere became unnecessary, even unthinkable. There was comfort in this solitude, a quiet reassurance that humanity stood at the heart of creation. Cracks in the silence. Still, curiosity has a way of seeping through even the thickest walls. During the Middle Ages, thinkers such as Fakhr al-Din al-Razi questioned whether creation might extend beyond humanity alone, drawing upon religious texts to suggest the existence of other worlds. By the 15th century, these questions grew bolder. William Vorlong wondered whether divine salvation might reach beings beyond Earth. And in 1440, Nicholas of Cusa offered a vision astonishingly ahead of its time. He proposed that Earth was itself a star, and that no place in the universe held a privileged center. To him, the sun and the stars alike could host life, each shining within an infinite, boundless cosmos. When Earth lost its throne, the great silence finally shattered in the 16th century. Nicholas Copernicus gently, but irrevocably, removed Earth from its throne. By placing the sun at the center, he transformed our world into just another planet, circling an ordinary star. From this shift flowed a powerful realization. If Earth is not unique in its position, perhaps it is not unique in its nature. Giordano Bruno took this idea to its boldest conclusion. He declared that every star was a sun, each surrounded by its own worlds, many of them alive. For this vision, he paid dearly, but his ideas seeded what we now call the Copernican and mediocrity principles, that neither Earth nor life itself occupies a privileged place in the universe. Then came Galileo. In 1610, his telescope revealed moons circling Jupiter, mountains rising on the moon, and the shifting phases of Venus. These were not distant lights, they were worlds, solid, structured, and real. Why do we search for life? And so, night travelers, we arrive at the heart of our obsession. Why do we spend vast resources sending silent machines into the dark? Why does this question refuse to let us rest? Arthur C. Clarke once offered a chilling reflection. Either we are alone in the universe, or we are not. Both possibilities are terrifying. If we are alone, then life is an extraordinary accident. A fragile flame flickering briefly in a vast, indifferent void. If we are not alone, then we are participants in a grand symphony, no longer solitary, no longer central. In truth, our search for life beyond Earth is a search for ourselves. We are asking whether life is a universal outcome of chemistry and physics, or a rare stroke of cosmic luck, a miracle or a grain of sand. This is the core of the millennium-long debate. Some scientists support the rare Earth hypothesis, arguing that while simple life may be common, complex intelligence is exceedingly rare. Earth, they say, won a series of cosmic lotteries: a perfect orbit for liquid water, a stabilizing moon, a protective magnetic field, and Jupiter standing guard against catastrophic impacts. Remove any one of these, and life might never have advanced beyond microbes. Others embrace the principle of mediocrity. The elements of life, carbon, oxygen, nitrogen, are forged in dying stars and scattered everywhere. With tens of billions of potentially habitable worlds in the Milky Way alone, it seems unlikely that Earth is the sole bearer of intelligence. Perhaps life is not a miracle, but a natural consequence of the universe itself. And so the question remains open, glowing softly in the night sky, patient, unresolved, and endlessly compelling. An unsolved obsession. We are still standing before what scientists quietly call the Great Silence. For more than 60 years, humanity has turned its giant ears toward the sky, listening patiently, attentively. Yet the universe has offered no clear reply. This unanswered question is known as the Fermi paradox. If life is common, where is everyone? Perhaps they are unimaginably distant. Perhaps they are watching us quietly, keeping their distance, as if we were inhabitants of a vast cosmic zoo. Or perhaps, most unsettling of all, we are the first to awaken in this immense dark chamber of existence. And yet, it is precisely this uncertainty that keeps the obsession alive. It urges us to continue digging into the ancient soil of Mars, to listen closely to the hidden oceans beneath Europa's frozen shell. It reminds us, gently but firmly, of the value of every calm breath we take on this fragile blue world. Night travelers, you have followed this long journey of thought, from the early musings of Epicurus to a modern science we now call astrobiology. You have seen how simple philosophical questions matured into careful observation and experiment, and you now know that the atoms that form your body tonight are the same ordinary elements scattered throughout the galaxy, forged long ago in the hearts of dying stars. Whatever the final answer may be, whether we are members of a vast interstellar community or the lone voice echoing through the void, this obsession remains one of humanity's most beautiful traits. It is proof of our curiosity, our humility, and our longing to connect. For now, feel safe in Earth's quiet embrace. Let visions of distant worlds, primordial oceans, and the first stars cradle your thoughts. Sleep gently, knowing that the greatest questions are still waiting. far out there, across space and time. Together, let us now focus on the question that has followed our species since the dawn of awareness. Why do we yearn so deeply to find life beyond Earth? Allow your mind to drift across the long ribbons of time. Listen to the whispers of the past. The search for life beyond our planet is, at its heart, a search for ourselves, for our place, our meaning, and our future within the endless flow of the universe. Arthur C. Clarke once offered a thought both simple and profound. There are two possibilities. Either we are alone in the universe, or we are not. Both are equally terrifying. Imagine standing alone in a silent field beneath a star-filled sky. If we are the only chapter in this cosmic story, then the universe is unimaginably empty and cold. But if there are other minds, elsewhere, looking up and asking the same questions we ask tonight, then our position changes entirely. We are no longer isolated. We are participants. This longing did not begin with rockets or radio telescopes. It took root thousands of years ago. Ancient Greek thinkers like Democritus and Epicurus spoke of countless worlds, reasoning that the same natural processes shaping life on Earth could not be confined to one place alone. At the same time, ancient Jain texts in India described many distant life-sustaining realms beyond the visible world. For nearly 15 centuries, Aristotle's geocentric model placed a heavy wall around these ideas, convincing humanity that Earth was central, unique, and alone. Yet even then, the dream of other worlds never vanished. It quietly endured. By 1440, Nicholas of Cusa dared to imagine Earth as a shining star among many, suggesting that every celestial body might hold the potential for life. The true turning point came when Nicholas Copernicus removed Earth from its cosmic throne and placed the sun at the center. Our world became ordinary, and in doing so, the universe became alive with possibility. Giordano Bruno took this idea further, declaring that every star was a sun, each with its own worlds and inhabitants. From these ideas emerged the principle of mediocrity. Earth does not occupy a special position, and life here is not so exceptional that it cannot arise elsewhere. Perhaps this is why we search so desperately. We struggle to accept that we might be nothing more than a fortunate chemical accident, a rare coincidence suspended in an indifferent void. At its core, this search is driven by curiosity, a deeply human force that propels civilization forward. Children explore naturally. When adults preserve that curiosity, we call them scientists. We send our steel and silicon messengers, like Perseverance on Mars or Da Vinci toward Venus, to listen for the quiet language of chemistry. We seek biosignatures, the faintest traces of life, because even the discovery of a single microscopic organism would reshape our understanding of biology and our place in the universe. It would mean that life is not a singular miracle belonging only to Earth, but a universal law written into the fabric of the cosmos itself. And in studying the universe, we are also, quietly and inevitably, searching for our own beginnings. Each of us, at our core, is a vast and delicate arrangement of chemistry, assembled from the same humble ingredients found throughout the galaxy: carbon, oxygen, nitrogen. These heavy elements were forged deep within ancient stars and released only when those stars ended their lives in supernovae. In the most literal sense, we are made of the dust of vanished suns. The search for life beyond Earth is our way of returning to that heritage, of asking whether the great symphony of life is being performed in other distant, temperate theaters beneath alien skies. And yet, an unsettling silence hangs over the universe, a silence scientists call the Fermi paradox. If there are billions of potentially habitable planets, where is everyone? Are they simply too far away? Are they quietly observing us as if we were inhabitants of some vast galactic zoo? Or, more somber still, do civilizations often undo themselves, undone by the very technologies meant to elevate them, long before they ever reach the stars. This, perhaps, is why our search feels so urgent. We are not only seeking neighbors, we are seeking reassurance. If we were to discover an ancient, enduring interstellar civilization, it would offer more than companionship. It would offer proof that it is possible to survive the perilous passage of technological adolescence, to guide a world safely into a distant future. But, traveler, there is also a quieter and more practical truth beneath this longing. Earth is not an eternal refuge. Our sun, though gentle and stable, grows brighter by about 1% every 100 million years. In roughly 1.1 billion years, that increased energy will disrupt Earth's carbon cycle, lowering carbon dioxide levels until photosynthesis can no longer continue. By 1.5 billion years, global temperatures will rise toward the boiling point of water, and the oceans themselves will slowly escape into space. Far beyond that horizon, the sun will swell into a red giant capable of consuming the inner planets, including our own. To search for them and for their worlds is also to search for a future shelter, a place where the story of humanity might continue when our first home can no longer sustain us. We are living in what could be called the early spring of the universe, a luminous and fertile era. But even this spring will not last. Trillions of years from now, stars like our sun will fade away, leaving only long-lived red dwarfs, burning faintly like the final candles in a darkening hall. In that far future, the search for life will no longer be about curiosity alone. It will be about ensuring that consciousness itself is not erased without a trace. We long to add a chapter to the immense archive of existence, to leave behind a record of what we learned about love and loss, curiosity and wonder. We seek others so that, in a universe slowly cooling toward darkness, it will be known that awareness once arose and that it shone. Tonight, as you feel the warmth of this fire, remember that you are already part of that great journey. The atoms within you carry the memory of ancient stars, and one day they will dissolve back into the quiet radiation of the cosmos, preserving the information of your existence in the only way the universe knows. Whether we are alone or not matters less than this, that we dared to look up and ask the questions that define us. We are stardust learning how to dream, a brief sentence on the opening page of a vast cosmic book still being written. Now, allow your body to fully relax. Feel your eyes grow heavy. Let your breathing fall into harmony with the deep, silent rhythm of the night. Release your worries about scale and uncertainty. Every molecule within you already belongs to a beautiful and orderly whole. The universe, immense and mysterious though it may be, is holding you gently tonight. You are safe on a planet that spent billions of years preparing for your presence in this very moment. Let thoughts of distant worlds, ancient oceans, and neighboring stars dissolve into the soft mist of sleep. The universe began in a radiant silence, and now, in its boundless symphony, it watches over your rest. Tonight, as the murmurs of the daytime world finally recede, I invite you on a journey into the darker layers of human understanding, where dreams of cosmic neighbors are no longer gentle fairy tales, but a dangerous game of hide-and-seek played beneath the stars. Welcome to Deadly Hide-and-Seek, the danger of darkness. Tonight, we will not dwell on the glory of discovery. Instead, we will listen carefully to the warnings whispered by some of the greatest minds humanity has ever known. We will ask a quiet but unsettling question. Could the search for extraterrestrial life be a path that leads us, slowly and unknowingly, toward extinction? Take a deep breath. Allow your thoughts to grow light. Let the immense silence of the universe carry this story gently into your sleep. Prelude: The Call of the Dark Forest. Dear night travelers, since the first spark of human awareness, We have looked up at the night sky and asked a single enduring question: are we alone? Arthur C. Clarke once observed, "There are two possibilities. Either we are alone in the universe, or we are not. Both are equally terrifying." For thousands of years, we have sent greetings into the darkness, radio waves filled with optimism, hope, and curiosity, waiting for a kind reply. But now, imagine the universe not as an open sky, but as an ancient forest at night, a forest where every civilization is a hunter moving silently between the trees. In such a place, any sign that reveals your position, a flicker of fire, the snap of a branch, can be fatal. And we, the young and fragile inhabitants of a small blue world, are calling out loudly in that forest, unaware that we may be drawing the attention of predators beyond our comprehension. A warning from modern sages. The search for extraterrestrial life is often praised as the highest expression of human curiosity. Yet for some, like Stephen Hawking, it was a deeply reckless act. In 2010, Hawking issued a stark warning: humanity should not attempt to contact advanced extraterrestrial civilizations. He compared such an encounter to the meeting between Native Americans and Columbus, an event that ended not in enlightenment, but in the collapse of entire cultures. From this concern arises a darker speculation, that advanced civilizations may have already exhausted their home worlds and now wander the galaxy as cosmic nomads, searching for new resources. To them, Earth would not be a place of friendship, but a valuable deposit to be harvested. For more than a century, our television broadcasts and radio transmissions have been leaking into space, transforming our planet into a brilliant lighthouse, shining brightly into the unknown, inviting every unseen gaze in the darkness. The Fermi paradox and the conspiracy of silence. If the universe is filled with habitable worlds, then where is everyone? This is the haunting question known as the Fermi paradox. Why have we heard nothing? Not even a whisper. One unsettling answer is known as the dark forest theory. It suggests that the universe is silent not because it is empty, but because silence is the only way to survive. Every civilization, once it reaches a certain level of technology, realizes two truths: that resources are finite and that expansion has no natural limit. Because no one can know whether another civilization is benevolent or hostile, and because technological growth can transform a harmless society into an existential threat within centuries, the safest strategy is simple: remain silent or eliminate potential rivals before they mature. Seen through this lens, projects like SETI or the Voyager Golden Records are not acts of curiosity, but declarations of our position, messages that could one day serve as our own indictment. The Great Filter, the Wall of Extinction. Another troubling idea is the Great Filter, a hypothetical barrier so difficult that almost no civilization survives it on the path from lifeless matter to interstellar intelligence. If we find no one else, there are only two possibilities. Either we are among the very few who have already passed the filter, or the filter still lies ahead of us, waiting silently in our future. Nuclear weapons, climate collapse, uncontrolled artificial intelligence, each technological triumph may also be a step closer to that invisible wall. Some fear that the universe is already a vast graveyard, filled with civilizations that destroyed themselves the moment they learned to speak across the stars. In that case, our search may not reveal thriving societies, but only the ruins of ambition, silent monuments to overreaching intelligence, the biological Trojan horse. Danger does not always arrive with weapons or fleets of spacecraft. Sometimes it comes in forms too small to see. When we send probes to worlds like Europa or Enceladus and imagine returning samples, we face the risk of reverse contamination. Alien microorganisms, however simple, may possess biochemistries entirely foreign to Earth. Our immune systems, shaped by terrestrial life, would offer no defense. Imagine a microbe born beneath an icy ocean, capable of surviving vacuum, radiation, and extreme cold. If released unintentionally, it could dismantle Earth's biosphere more efficiently than any invasion force. Perhaps this is why space agencies enforce such strict planetary protection protocols, not from fear of invasion, but from fear of microscopic catastrophe. The zoo hypothesis, the silent watchers. There is another possibility, one that is both strangely comforting and deeply unsettling. The zoo hypothesis suggests that extraterrestrial civilizations are already aware of us. They may even be nearby, observing quietly, as we observe animals behind glass. Perhaps Earth has been placed under a kind of quarantine, allowed to evolve naturally without interference. Yet the darker implication remains. Observation can precede intervention, or exploitation, or harvest. Our failure to detect them may not mean absence, but superiority. Technologies so advanced they render us blind. Like children knocking on a giant's door, we may not realize that once it opens, our familiar world could vanish forever. The trap of curiosity and the silent escape. Perhaps our search for Earth 2.0 is not about companionship at all, but escape. Earth, though beautiful, is fragile. It has endured 5 mass extinctions and faces an inevitable future beneath a warming sun. Our longing for distant worlds like Kepler 452b or Proxima b may be an ancient survival instinct, urging us to prepare for the day our first home can no longer shelter us. Yet escape carries its own danger. To live on another world is to change, biologically, culturally, fundamentally. In time, we might no longer recognize ourselves. We could even return as strangers or adversaries to the planet that gave us birth. This game of hide and seek, then, is not only between us and them, but within the soul of humanity itself. Behind the gentle shimmer of the stars may lie watchful eyes, extinction barriers, and invisible dangers. Curiosity is the fire that warms the universe, but without wisdom, it can also consume us. Whether the cosmos is a dark forest or a silent zoo, tonight you are safe. You rest within the quiet embrace of Earth. Let thoughts of lonely radio signals, drifting starships, and unseen neighbors dissolve into the soft haze of dreams. Together, we will attempt to decode a quiet but unsettling theme. Searching for a home. Are we running away? Tonight, we will not speak of the beauty of distant worlds. Instead, we will linger on a more troubling thought. Is our journey toward the stars truly an act of exploration, or is it a silent escape from a destiny already written for Earth? Take a slow, deep breath. Let your heartbeat fall into step with the eternal rhythm of space, and begin listening to the story of travelers who may, in truth, be trying to save themselves. For thousands of years, humanity has lifted its eyes to the sky and asked the same restless question: are we alone? From ancient Greek thinkers like Democritus and Epicurus to wandering minds such as Giordano Bruno, countless voices have imagined a universe filled with inhabited worlds. Yet when we look closely at the realities of the 21st century, a darker suspicion quietly emerges behind billion-dollar missions. Perhaps we are not only searching for neighbors, but desperately seeking a planet B. Why does the idea of escape resonate so strongly within us? To understand this, we must face an uncomfortable truth. Earth, this solitary blue jewel known to host life, is not an impregnable sanctuary. Its history is not one of uninterrupted harmony, but a long struggle for survival amid catastrophe. At least 5 mass extinctions have scarred this planet, moments when 95 to 99% of all life vanished. Each time, survival came only through narrow and fragile openings in fate. Traveler, we live in an era where stability is merely an illusion when viewed through deep time. Scientists have quietly written a kind of death sentence for our home, based on the inevitable evolution of our parent star. The sun is aging, slowly, relentlessly. Every 100 million years, its brightness increases by roughly 1%. In about 1.1 billion years, intensified radiation will disrupt Earth's carbon cycle, lowering carbon dioxide levels until plants can no longer perform photosynthesis. By 1.5 billion years, global temperatures will approach 100 degrees Celsius, and Earth's oceans will evaporate into space. In the distant finale, the Sun will expand into a red giant, consuming Mercury, Venus, and perhaps Earth itself. Is it possible that, deep within our collective subconscious, humanity already senses the planet's expiration date? Our fascination with worlds like Kepler 186f or Proxima Centauri b may not be curiosity alone, but an ancient survival instinct stirring within our genes, urging us to find an exit before our old home is burned away by stellar fire. As Arthur C. Clarke once observed, either we are alone or we are not alone. Both are equally terrifying. Yet if we were to find them, it would offer proof that long-term survival is possible, that a civilization can endure beyond its dangerous technological adolescence. But is escape truly within our reach? Consider the numbers that quietly unsettle the mind. Proxima Centauri b, the nearest potentially habitable world, lies 4.3 light-years away. With today's technology, such a journey would require approximately 165,000 years. If we began tonight, countless generations would be born and die in the cold darkness between stars, never seeing a true sun, never standing upon the soil of Earth. These future voyagers would no longer be human as we know ourselves, changed by low gravity, altered physiology, reshaped immune systems, and profound psychological transformation. To flee Earth's fate, must we surrender our very humanity? There is an even darker idea, known as the Great Filter. It proposes that an invisible barrier eliminates civilizations before they can ever truly reach the stars. If we find no one else, it may be because they all failed, destroyed by the very tools they created for salvation: uncontrolled artificial intelligence, nuclear conflict, or biological catastrophes carried across worlds. At times, the search for a new home resembles a grim conspiracy of inequality. Could visions of floating cities in Venus's clouds or subterranean shelters on Mars be intended only for a privileged few, while the majority are left behind to face planetary decline? From this shadowed perspective, space exploration appears less like discovery and more like the construction of a selective ark, built from Earth's final reserves of steel and silicon. Yet, night traveler, look into this fire and allow another thought to surface. If life on Earth began through panspermia, if we are, in some sense, seeds carried here from distant stars, then our return to the cosmos is not an act of cowardice. It is a homecoming, a solemn responsibility to protect and carry forward the fragile flame of consciousness. Earth has spent 4 billion years shaping us, perhaps so that one day we might become the vessel through which life spreads into the cold, silent universe. Are you still there, night travelers? If your eyes remain open, welcome to a finale for deep sleep amid the ocean of stars. Tonight, we set aside spacecraft and technology and drift inward, toward the quiet place where dreams of cosmic neighbors have smoldered for millennia. We ask one final question: why does humanity search so desperately for life beyond Earth? And what does this journey mean for our brief existence beneath the eternal sky? Breathe slowly. Let your heartbeat blend with the rhythm of nothingness, and listen to the story of travelers searching not only for others, but for themselves. The longing to find life beyond Earth did not begin with rockets. It was born with human awareness itself. Long before artificial lights dimmed the Milky Way, thinkers like Democritus and Epicurus spoke of infinite worlds. Epicurus believed that the same natural forces that shaped life on Earth must also act elsewhere, because an infinite universe does not repeat itself only once. For more than 1,000 years, Humanity clung to the belief that Earth was the singular center of creation. Yet even then, whispers of other worlds refused to die. In the 15th century, Nicholas of Cusa dared to imagine Earth as merely one brilliant star among many, each capable of harboring life. Later, Copernicus and Giordano Bruno shattered the illusion entirely, declaring that every star is a sun with its own worlds. Bruno paid with his life, but his vision endured. Earth is not unique, and life is not an isolated miracle. Why then can we not stop searching? Why do we send steel and silicon messengers, rovers, telescopes, silent observers, into the darkness, chasing the faintest trace of life? Because the search itself is a mirror. To seek others is to ask who we are. Are we a universal consequence of chemistry or a fleeting accident? The discovery of even a single microbe beyond Earth would reshape biology forever, proving that the music of life plays throughout the cosmos, and we are only one note within it. More than curiosity, this search carries hope. We are a civilization navigating a dangerous adolescence, wielding tools more powerful than our wisdom. If we find a civilization that has survived long enough to age among the stars, it would show us that endurance is possible, that we too may yet guide our world into a future measured not in centuries, but in eons. And with that thought, night traveler, allow your mind to grow quiet. The stars will continue their silent watch. And for now, Earth still holds you gently, beneath a sky filled with questions waiting patiently for tomorrow. A game of hide and seek in the dark jungle. But, night travelers, there is a shadow side to this noble aspiration. The search for extraterrestrial life is not only a romantic quest filled with wonder, it may also be a perilous game of hide and seek played in the deepest darkness. Stephen Hawking once cautioned that humanity should think very carefully before attempting to contact extraterrestrial civilizations. He warned that the outcome might resemble the tragic encounter between Native Americans and Columbus, a meeting between worlds that ended in devastation rather than enlightenment. Consider for a moment the dark forest theory. Imagine the universe as an ancient, silent jungle. Every civilization is a cautious hunter, moving quietly through the undergrowth. In such a place, revealing your position, sending out a signal, a greeting, a declaration of existence, could be a fatal mistake. The safest strategy is not friendship, but silence, not greeting, but preemptive elimination of any potential rival. Perhaps the great silence of the universe, the mystery known as the Fermi paradox, is not proof that no one is there. Perhaps it is evidence that everyone has learned the same lesson. To survive, one must remain unseen. The danger may come not from fleets or weapons, but from something far smaller. Cosmic pathogens, viruses or bacteria born on another world, could devastate our biosphere far more efficiently than any hostile invasion. Our immune systems, shaped by Earth alone, would have no defense against truly alien biochemistry. This is why space agencies enforce strict planetary protection protocols, guarding against the nightmare of reverse contamination, a catastrophe that could begin invisibly and end everything we know. Are we running away from destiny? And now, night travelers, we arrive at a question that quietly lingers beneath all others. Is the search for an Earth 2.0 truly an act of hope? Or is it a silent retreat from destiny itself? Earth is a radiant jewel, but it is also fragile. Its history is marked by at least 5 mass extinctions, and its distant future is already written in the slow evolution of our sun. Every 100 million years, the sun grows roughly 1% brighter. In about 1.1 billion years, this increasing radiation will disrupt Earth's climate so profoundly that oceans will evaporate, plants will lose the ability to photosynthesize, and complex life will quietly fade away. Far beyond that, the sun will expand into a red giant, eventually engulfing the inner planets, perhaps even our home. Humanity's longing for worlds such as Proxima Centauri b or Kepler 452b may be more than curiosity. It may be an ancient survival instinct resurfacing, urging us to search for an exit before our birthplace is consumed by stellar fire. Yet this escape is anything but simple. With current technology, a journey to Proxima Centauri b, over 4 light-years away, would require tens of thousands of years. Countless generations would be born and die in the frozen darkness between stars, never seeing a true sunrise, never touching Earth's soil. These future voyagers would not be human in the way we understand ourselves today. Their bodies and minds would be reshaped by radiation, isolation, and the absence of gravity. Perhaps, to outrun destiny, we would have to relinquish our very humanity. As we stand beside a fading fire, gazing upward at the shimmering lights above, let us recognize something quietly profound. Humanity's curiosity is itself a flame, a small but stubborn warmth in a vast, indifferent universe. Whether we search for friends, for origins, or for refuge, the journey stands as a testament to our will to live, to endure, and to understand. We are specks of stardust learning how to dream. We are a brief sentence on the opening page of an immense cosmic book that has yet to be written. Whether we are alone or not may matter less than this simple truth. We dared to look up and ask the greatest questions. If giants exist among the stars, we may one day meet them. If not, then perhaps we are meant to become giants ourselves, carrying the fragile torch of life and consciousness into the distant future of the Milky Way. Now, let thoughts of ocean worlds, faint radio whispers, and drifting starships dissolve into the soft mist of dreams. Feel the quiet reassurance that you are an inseparable part of this long journey. The atoms within you, the iron in your blood, the minerals in your bones, were forged in stars that exploded billions of years ago. You are the memory of ancient suns, still moving forward through space and time. Close your eyes. There is nothing left to escape, nothing left to fear. Only stillness remains, and the gentle glow of the Milky Way surrounding you. The universe began in profound silence, and now, with boundless patience, it guards your sleep. Are you still here, night travelers? If you have already drifted into sleep, that is perfectly all right. And if you are still awake, welcome back to our quiet refuge at the Night Observer, a place for calm minds and wandering thoughts beneath the vast and mysterious universe. Let your body sink into the bed. Release the tension in each muscle. Let your breath move slowly, like dust drifting between galaxies, as we begin our story of beginnings. Tonight's chapter is called When the Earth Was Still, a Brief History of the Beginning. This is not the tale of a gentle blue world with calm oceans and green fields. It is the story of violence, fire, and chaos. A brutal cradle in the heart of space where life seemed impossible. Breathe deeply. Allow your thoughts to lighten and listen to the story of the world before it learned how to live. A prelude from the ruins of the stars. Our story begins long before Earth itself. To understand where we come from, we must look upward and recognize that we are inseparable from the stars. Around 13.8 billion years ago, the universe emerged from the event we call the Big Bang. In its first moments, temperatures soared to billions of degrees, and life could not yet exist. The cosmos contained only the simplest elements: hydrogen, helium, and traces of lithium. Hundreds of millions of years passed before gravity gathered these vast clouds of gas into the first stars, the universe's great forges. In their dense, blazing cores, light elements fused into heavier ones: carbon, oxygen, nitrogen, iron, the very materials that form your body tonight. And for those elements to reach us, those stars had to die. In their explosive supernova deaths, they scattered these chemical seeds across space. We are, in the most literal sense, made from the remnants of fallen stars. Fast forward to about 4.6 billion years ago. In a quiet corner of the Milky Way, a cloud of dust and gas collapsed under its own weight, giving birth to our solar system. Most of the material formed the sun, while the rest flattened into a swirling disk where planets slowly took shape amid relentless collisions and fire. The birth of a hell. Earth came into existence roughly 4.54 billion years ago. But do not imagine oceans or skies just yet. During the Hadean Eon, named after Hades, the underworld, Earth was a world utterly hostile to life. If you could have stood on its surface, there would have been no solid ground beneath your feet, only a vast ocean of molten lava glowing red against the blackness of space. Temperatures exceeded 1,200 degrees Celsius, hot enough to destroy any organic molecule instantly. This inferno was fueled by leftover heat from planetary formation and the decay of radioactive elements deep within the young Earth. Above, the sky was not blue, but thick and suffocating. A pale orange haze filled with carbon dioxide, nitrogen, methane, and water vapor. Oxygen was entirely absent. The air was dense, turbulent, and crushing. Early Earth was not a home. It was a roaring furnace, a planet still learning how to exist. The fatal collision and the devastation of Theia. While Earth was still engulfed in flame, still struggling to find balance, the most catastrophic event in its early history unfolded, an event scientists now call the Giant Impact Hypothesis. A young planetary body, roughly the size of Mars and known as Theia, was drawn toward Earth along a fateful path. Theia approached at a terrifying velocity, nearly 15 kilometers per second, many times faster than any projectile known to us today. The collision was not a direct hit, but a glancing, tilted impact, one that twisted and deformed the very structure of the young Earth. The force was unimaginable. The crusts of both worlds were torn apart, and trillions of tons of incandescent rock were hurled into space. Earth did not shatter, but it absorbed much of Theia's mass, melting once again into a global ocean of liquid magma. From this ring of fire and dust, something extraordinary emerged. In less than a century, the moon was born. At its birth, this silent companion hovered far closer than it does today, only about 22,500 kilometers away. Its immense gravitational pull unleashed colossal tidal forces. Vast waves of molten lava surged endlessly across Earth's surface, erasing any hope of geological calm. At the same time, Earth spun at a dizzying pace. A single day lasted no more than 6 hours. Winds stronger than any storm we can imagine tore through a toxic atmosphere. Space, time, and matter themselves seemed caught in a state of relentless turmoil. The late bombardment phase, a rain of fire from heaven. Even as Earth slowly began to cool, the universe continued its harsh examination. Around 4 billion years ago, the solar system entered a violent era known as the Late Heavy Bombardment. The shifting orbits of massive planets such as Jupiter and Saturn flung countless comets and asteroids inward toward the fragile rocky worlds. For tens of millions of years, Earth endured an unceasing barrage. Each impact struck with the force of thousands of atomic bombs, vaporizing early oceans and reheating the planet's surface to devastating extremes. And yet, within this destruction lay a quiet paradox. These celestial attackers carried salt crystals, microscopic droplets of water, and prebiotic organic molecules, the raw ingredients of life itself. They were both destroyers and messengers, threatening to erase fragile beginnings while delivering the seeds of future possibility. Earth became a battlefield of fire and ice, its surface scarred by enormous craters, resembling the desolate face of the moon we see tonight. The methane atmosphere and the absence of protection. For hundreds of millions of years, Earth lacked the gentle protection it enjoys today. The young sun was restless and fierce, unleashing violent solar storms and torrents of ultraviolet radiation. Deep within Earth, The core was still forming and stabilizing. Its magnetic field was weak, unable to shield the planet from the relentless solar wind. Streams of charged particles battered the atmosphere, stripping it away layer by layer. The surface lay exposed to lethal radiation, making the survival of complex organic molecules on land nearly impossible. There was no ozone layer to soften the sun's glare. Without it, ultraviolet rays scorched the planet. The air was thick with poisonous gases: ammonia, hydrogen sulfide, cyanide. It was a world where the atmosphere would have smelled of rust and decay, a place where even the simplest cell fought constantly against pressure, heat, and radiation. Earth was not yet a cradle of life. It was an open wound in space. We now turn our gaze inward, no longer merely admiring distant stars, but stepping directly into what might be called creation's recipe, the intricate and delicate process by which breathing beings arise from emptiness. The search for life is, at its heart, a search for ourselves, to understand who we are and what we might yet become within the endless river of space and time. Arthur C. Clarke once reminded us, there are two possibilities. Either we are alone in the universe, or we are not. Both are equally terrifying. If we are the sole chapter in the book of life, then the universe is profoundly lonely. And yet, to write even a single line in that book, the cosmos had to prepare a perfect kitchen, rare ingredients, precise conditions, and an extraordinary balance where the slightest mistake could erase everything. Take a slow breath. Let your heartbeat fall into rhythm with the silence around you, and listen now to the story of the miraculous building blocks of existence. Raw materials from the forge of departed stars. Dear night travelers, before life could begin its quiet symphony, the universe first needed the right materials. In the beginning, there was only a single, simple note. 13.8 billion years ago, the Big Bang brought space and time into being in a state of unimaginable heat, so intense that no form of life could exist. In that first moment, temperatures soared to billions of degrees, and the universe contained only the lightest elements: hydrogen, helium, and a trace of lithium. From these alone, no cell could form, no leaf could grow, no heart could ever beat. The universe needed variety, and to create it, something luminous had to be sacrificed. The first stars, vast, brilliant, and short-lived, became the great forges of creation. Within their searing cores, lighter elements fused into heavier ones in a strict cosmic order. And here lies the profound paradox. For these elements to become part of us, the stars themselves had to die. When they exhausted their fuel and exploded as supernovae, they scattered their chemical riches across space. We are, quite literally, made from this stellar debris. Every atom in your body tonight carries the memory of a star that lived and died billions of years ago. Once these elements were prepared, creation's recipe began to combine three essential notes, transforming lifeless chemistry into living biology. The first ingredient is energy. Life requires a driving force to power its chemical reactions. This energy may come from the gentle light of a star like our sun, or from the deep geothermal heat rising from Earth's interior. But it must be precisely balanced. Too much and fragile bonds are destroyed. Too little and all motion ceases. The second ingredient is chemical diversity. Life is a complex arrangement of matter, built primarily from 6 elements: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Among them, carbon stands as the master architect. With its ability to form 4 strong bonds, carbon can bend, twist, and connect into the intricate chains that form DNA and RNA. It is found everywhere, from distant nebulae to ancient meteorites, suggesting that the universe itself is generous in supplying the framework for life. The third, and perhaps most wondrous ingredient, is liquid water. Imagine atoms as guests at a gathering. In a gas, they rush past one another too quickly to connect. In a solid, they are locked rigidly in place. Only in a liquid, especially water, can molecules move freely, meet, and bind into complex structures. Water is not merely a solvent, it is a stable stage upon which the quiet drama of evolution can unfold, step by careful step. Setting up the cosmic kitchen, the Goldilocks zone, and Earth's oddities. The universe is vast beyond imagination, yet not every corner of it can become a stage for the symphony of life. Astronomers refer to the ideal region around a star as the habitable zone, or more gently, the Goldilocks zone, a place where conditions are just right. At this precise distance, a planet is neither scorched by relentless heat nor locked in eternal ice, allowing water to exist steadily in its liquid form upon the surface. But, dear travelers, simply residing within the Goldilocks zone is not enough. Earth is a fortunate and rather unusual case. When we peer into distant planetary systems, we often find massive super-Earths orbiting perilously close to their stars. Our own solar system, however, follows a remarkably orderly design. This may be due to its early and powerful conductor, Jupiter. Forming rapidly and growing immense, Jupiter created a gravitational barrier that blocked streams of material from flooding the inner system. In doing so, it kept Earth and Mars small and rocky, sparing them from becoming hot, bloated worlds incapable of nurturing life. Earth is also equipped with invaluable protective companions. Deep beneath our feet, a rotating ocean of molten iron generates a powerful magnetic field, shielding the planet from the relentless assault of charged particles carried by the solar wind. Without this invisible armor, our atmosphere would have been stripped away long ago, leaving Earth as barren and lifeless as Mars. And then there is the Moon, our quiet guardian. Unusually large for a planet of Earth's size, it stabilizes our axial tilt, preventing wild swings in climate. Because of the Moon, Earth has enjoyed billions of years of relative stability, a gentle rhythm of seasons that granted life the patience of time to grow, adapt, and endure. Abiogenesis, when chemistry awakens into biology. How did lifeless chemicals cross the vast threshold into biology? This remains one of humanity's deepest mysteries, known as abiogenesis. It was not a single dramatic moment, but a slow ascent, a long journey toward increasing complexity. In the 1950s, hope flickered when Stanley Miller and Harold Urey conducted a now famous experiment. They recreated Earth's primordial atmosphere inside a glass apparatus, sending electrical sparks, stand-ins for ancient lightning, through a mixture of early atmospheric gases. Within a week, the once clear water turned murky brown, rich with amino acids, the fundamental building blocks of proteins. This simple experiment revealed something profound. The ingredients of life could arise naturally and surprisingly quickly. Yet ingredients alone do not make a living system. Life faced a paradox of roles, information, and labor. In modern organisms, DNA stores instructions, while proteins perform the work. But DNA requires proteins to replicate, and proteins depend on DNA for their blueprint. Which came first? The answer likely lies in a versatile molecule, RNA. In an early RNA world, these molecules could both store genetic information and catalyze chemical reactions. With RNA, chemistry began to resemble life itself, capable of heredity, variation, and self-replication. Life also needed a boundary. Lipid molecules naturally formed double-layered membranes, enclosing RNA and energy within a protected space. These membranes created an internal world, shielded from external chaos, where reactions could occur more efficiently. When such protocells began to divide, life, true life, had quietly arrived. Resilience amid the storm of fate. Dear night travelers, the journey from simple molecules to Luca, the last universal common ancestor of all life, is a story of remarkable endurance. 4 billion years ago, Earth was far from tranquil. During the late heavy bombardment, countless meteorites rained down, repeatedly threatening to boil away the oceans themselves. Yet life revealed its most astonishing quality: resilience. Rather than clinging to the planet's violent surface, early life likely retreated into the depths, into hydrothermal vents on the ocean floor. There, in perpetual darkness, it learned to harness chemical energy rising from Earth's interior, surviving beyond the reach of catastrophe. These early extremophils remind us that life does not require paradise. It needs only a narrow opening through which it can take hold. Look around you tonight, from frozen mountain peaks to the deepest ocean trenches, and you will see echoes of that resilience. Every breath you take is the outcome of countless improbable events in this vast cosmic kitchen. That we exist at all on a planet that has spent 4 billion years taming the universe's most violent forces may be the greatest miracle of them all. The perfect home. Why Earth? Night travelers, let us now gather our thoughts for the perfect home. Why Earth? Together, we will unravel the delicate codes of creation, the intricate arrangements that transformed this small world into a singular haven of life amid the cold, silent sea of space. Take a slow breath. Let your heartbeat settle into the eternal rhythm of the cosmos and listen to the story of how a miracle found its home. A destined peace in the silent expanse. Our story begins in quiet darkness, within a vast cloud of dust and gas some 4.6 billion years ago. Along the Orion arm of the Milky Way, this spinning protoplanetary disk gave birth to the dancers of the solar system. Of the 8 planets that emerged, only one received the precise combination of conditions needed to nurture life. Earth is not merely a wandering rock. It is the result of a cosmic lottery in which every number aligned. Life, as we know it, demands a rare balance of energy, chemistry, and stability. To create this home, the universe had to assemble a kitchen so delicately prepared that even the smallest misstep could have reduced everything to dust. The just right location, a blessing of the Goldilocks region. The first and most fundamental gift Earth received was its location. Within the Goldilocks zone, we orbit at a distance that is neither too close nor too far from the sun. Venus, nearer the fire, lost its water to runaway heat. Mars, farther away, froze into silence. Here, sunlight arrives gently, strong enough to fuel life's chemistry, yet soft enough to preserve it. This fragile balance allows water to exist in liquid form across Earth's surface. Remarkably, Earth is the only planet in our solar system where water naturally exists as solid, liquid, and vapor, sustaining a dynamic cycle that touches every living cell. And so, in this narrow and improbable corridor of space, life found not just a foothold, but a home, a magnetic shield, and a burning iron heart. But, dear traveler, a beautiful location alone is never enough. To protect the fragile breath of life, Earth needs a shield, and remarkably, it forges that shield from deep within itself. Earth is the densest planet in the solar system, built around a metal-rich heart of iron and nickel. It is the slow, ceaseless motion of this liquid outer core that generates a powerful global magnetosphere. Invisible yet vigilant, this magnetic field stands guard, deflecting most of the dangerous charged particles carried by the solar wind and cosmic radiation. Without it, our atmosphere would have been gradually peeled away, just as Mars lost its own protection some 4 billion years ago, leaving behind a barren red desert. Earth, by contrast, keeps its breath alive, sustained by the quiet fire of its iron heart, the symphony of the atmosphere and the silk curtain of ozone. As you take a deep breath tonight, remember this: the air filling your lungs is a masterpiece shaped by time. Earth's atmosphere, composed of 78% nitrogen and 21% oxygen, is not an accident. It is the result of billions of years of intimate cooperation between the planet and life itself. In the earliest ages, the sky glowed faintly orange, heavy with carbon dioxide and methane. Then came a silent revolution. Ancient cyanobacteria learned to harness sunlight through photosynthesis, releasing oxygen into the air and triggering what we now call the Great Oxidation Event. Oxygen became not only the gas of breath, but also a guardian. Rising high into the atmosphere, it interacted with sunlight to form the ozone layer, a delicate silken curtain that shields life from deadly ultraviolet radiation. Thanks to this protection, life could leave the safety of the oceans, step onto land, and eventually lift its eyes toward the stars. Meanwhile, trace amounts of greenhouse gases such as carbon dioxide and water vapor wrapped the planet in a gentle thermal blanket. Without it, Earth's average temperature would plunge to a frozen -18 degrees Celsius. With it, the world rests at a life-friendly 15 degrees, a narrow comfort zone where life can flourish. The moon is the nanny and Jupiter is the conductor. Earth did not build this paradise alone. It has companions, quiet partners in a long cosmic dance. First among them is the moon, unusually large for a planet of Earth's size. Born from a cataclysmic collision with a protoplanet known as Theia, the moon now uses its steady gravitational pull to stabilize Earth's rotational axis. Without this calming influence, our planet would wobble unpredictably, plunging from scorching heat to deep freeze. Conditions too extreme for complex life to survive. The moon also raises the tides, stirs the oceans, dissolves minerals, and helps create the chemical richness of the primordial seas from which life first emerged. Farther out waits Jupiter, the great conductor of the solar system. With a mass 2.5 times greater than all the other planets combined, its immense gravity shapes the rhythm of planetary motion. Jupiter acts as a cosmic shield, capturing or deflecting many dangerous asteroids before they can strike the inner worlds. At the same time, it likely played a role in delivering water-rich objects from the outer regions to the young Earth, supplying the lifeblood of our oceans. Why are we unique? Night travelers, have you ever wondered why, as we look across our neighboring worlds, we do not yet find life staring back at us? The answer lies not in a single factor, but in the absence of the delicate combination that Earth so improbably possesses. Consider Venus, our so-called twin in size. Though it lies within the Sun's habitable zone, it is trapped in a runaway greenhouse effect. A dense carbon dioxide atmosphere presses down with 90 times the surface pressure of Earth, while temperatures soar to 464 degrees Celsius. Liquid water cannot exist there. Venus lacks both active plate tectonics to recycle carbon and a strong magnetic field to guard its atmosphere. Then there is Mars, the rust-colored neighbor. Long ago, it hosted rivers and oceans, but its smaller size sealed its fate. Cooling too quickly, Mars lost its magnetic field. The solar wind stripped away its atmosphere and water, leaving behind a cold, fragile desert. Earth stands between these two extremes, balanced like a perfectly tuned symphony. We share Mars's ancient water, yet we preserve it, thanks to protections Venus never had. Tonight, let your body sink deeper into the comfort of your bed. Release the tension in your shoulders. Feel warmth spreading gently from your chest to your fingertips. We live in an age when humanity no longer only dreams of the cosmos, but has begun to reach out, sending emissaries of steel and silicon into the dark. Welcome to The Call of Space, Potential Destinations. This chapter speaks of our messengers, of hidden oceans beneath frozen shells, and of distant planets whispering chemical hints of life. Let the silence of space slow your thoughts and listen carefully to the story of possible havens, future homes, or perhaps others waiting among the stars. The messengers of the red planet. Our first destination is Mars, the mesmerizing red world that has haunted human imagination for centuries. Once we dreamed of vast canals and ancient civilizations. The reality returned by our probes is colder and quieter, but no less compelling. Picture Jezero Crater. Billions of years ago, this was not a desert, but a lake fed by flowing rivers, carrying sediments and perhaps the seeds of life. Today, the Perseverance rover roams this ancient shoreline, extending its mechanical arms to drill into rock and soil, searching for biosignatures, faint fossil whispers of microorganisms that may have lived when Mars was green. One mystery continues to puzzle scientists: the sudden appearance of methane plumes in Mars's thin atmosphere. On Earth, methane is often a sign of life. While it can arise from geological processes, the possibility of dormant microbes deep beneath the Martian surface remains tantalizing. The discovery of even a single bacterium would rewrite biology itself, proving that life is not a singular accident, but a recurring expression of the universe, a cloudy paradise on Venus. Leaving the frozen silence of Mars, we drift toward Venus, Earth's twin in form, but not in fate. Where Earth is a garden, Venus's surface is an inferno, hot enough to melt lead and crushing beyond imagination. Yet, night travelers, the story does not end at the surface. Rise about 50 kilometers into the clouds, and conditions soften. Pressure and temperature there resemble a mild spring day on Earth. In 2020, scientists detected traces of phosphine in these cloud layers, a gas that, on our planet, is usually produced by life in oxygen-poor environments. Could it be that when Venus's surface became uninhabitable, life retreated upward, adapting to exist within droplets of sulfuric acid? In 2029, NASA's Da Vinci probe will plunge through these clouds, seeking answers firsthand, and perhaps revealing whether a hidden microbial world floats high above a scorched planet. The dark oceans beneath the ice. Perhaps the most promising homes for life are not found on planetary surfaces at all, but beneath thick ice, far from sunlight. In these distant realms, energy flows not from the sun, but from gravity itself. Imagine Europa, one of Jupiter's moons, a bright sphere etched with countless fractures. Beneath its icy shell, tens of kilometers thick, lies a global ocean containing more water than all of Earth's seas combined. Tidal forces from Jupiter knead Europa's interior, generating heat and sustaining liquid water in perpetual darkness. At the ocean floor, scientists suspect hydrothermal vents, sources of warmth and chemistry, similar to the cradles where life may have begun on Earth. In such depths, complex organisms could exist, unseen, communicating through unfamiliar biological signals. Nearby, Saturn's tiny moon Enceladus offers open invitations. From its south pole, vast plumes of water and organic molecules erupt into space. The Cassini spacecraft once flew through these geysers, detecting salts, organic compounds, and hydrogen cyanide, a key ingredient for proteins. Enceladus seems to whisper across the void, "Come closer. Life may already be here." Titan, an Earth in a refrigerator. And then there is Titan, the strangest world in our solar system. Titan is the only celestial body besides Earth known to host stable lakes on its surface. Yet these lakes are not filled with water, but with liquid methane and ethane. On Titan, water is locked away as solid ice, and the familiar solvent of life has been replaced by hydrocarbons. Its thick atmosphere, rich in nitrogen and complex organic compounds, bears an uncanny resemblance to that of early Earth before life began. Scientists often describe Titan as an Earth in a refrigerator. While any life here would be profoundly alien, perhaps based on silicon chemistry or moving through unimaginably slow metabolic rhythms, the sheer abundance of organic material makes Titan a natural laboratory of creation. In the coming years, NASA plans to send a drone named Dragonfly to soar above Titan's organic dunes, searching for forms of existence that may lie beyond our current imagination. Super-Earths and Hycean worlds. Leaving the shelter of our solar system, we extend our gaze outward to the thousands of planets orbiting distant suns. Thanks to missions like Kepler and the James Webb Space Telescope, we now know that roughly 1/4 of stars host rocky planets within the so-called Goldilocks zone. Consider K218b, a world 124 light-years away. It is not an Earth-like planet, but a super-Earth, wrapped in a hydrogen-rich atmosphere and possibly covered entirely by a global ocean of liquid water, a Hycean world. James Webb has detected methane, carbon dioxide, and most intriguingly, traces of dimethyl sulfide. On Earth, this molecule is produced only by life, primarily by ocean-dwelling phytoplankton. The thought of a living ocean world calling to us across trillions of kilometers is nothing short of breathtaking. Or look to the TRAPPIST-1 system, where 7 rocky planets orbit a small red dwarf star. At least 3 lie within the habitable zone. Each is a blank page, waiting for its own history, its own chance to inscribe a chapter in the story of life. We also cannot ignore Kepler 452b, often described as Earth's older twin. It orbits a sun-like star and has remained in the habitable zone for nearly 6 billion years, 1.5 billion years longer than Earth. Time enough, perhaps, not only for life to arise, but for intelligence to emerge. Future havens for humanity. As we search anxiously for them, we are also, quietly, searching for a future for ourselves. Earth is a radiant but fragile jewel. Its history records at least 5 mass extinctions, and our sun continues to age, growing hotter with each passing 100 million years. Proxima Centauri b, just 4.2 light-years away, stands as the nearest potential refuge. Though it may be tidally locked, one side scorched by perpetual daylight, the other locked in eternal night. The narrow twilight zone between them could offer temperate conditions. Our desire to find such worlds is not mere curiosity. It is a survival instinct, written deep within our genes, urging us to look outward before our first home becomes uninhabitable. The Symphony of Perseverance. Night travelers, the search for habitable worlds reveals a profound truth. The universe is generous with opportunity. Within the Milky Way alone, there may be 50 billion potentially habitable planets. Each point of light in the night sky represents a possibility, a story no less intricate than our own. Whether we listen for the great silence or analyze faint chemical fingerprints in alien atmospheres, the longing for connection burns steadily within us. Our explorers, radio signals drifting through space, robots crawling across Martian soil, are the opening notes of humanity's attempt to leave its cradle and join the greater symphony of the cosmos. Night travelers, find a comfortable position in your bed. Let your shoulders soften. Feel warmth slowly spreading from your chest to your fingertips. As the noise of the daytime world fades, allow your thoughts to follow me into one of humanity's deepest questions. Welcome to the game of hide and seek in the void, difficulties and challenges. This chapter speaks not of dreams, but of reality, of an era in which humanity has begun sending messengers of steel and silicon into the darkness, searching for its cosmic counterparts. We will visit distant worlds, descend into hidden oceans, and confront the chilling risks that await us beyond Earth. Let your breath grow lighter. Let your mind drift into the deep oceans of space. The candidates in the galactic hide and seek. In this vast game of hide and seek, we have learned that our galaxy is an ocean crowded with planets. With more than 200 billion stars in the Milky Way and trillions of worlds that may exist, the idea that Earth alone hosts intelligent life becomes increasingly difficult to accept. K2-18b, a Hycean world full of hope. Among the most compelling candidates is K2-18b. Observations from the James Webb Telescope reveal methane, carbon dioxide, and traces of dimethyl sulfide, produced on Earth almost exclusively by living organisms. Classified as a Hycean world, it may be entirely covered by a global ocean beneath a hydrogen-rich atmosphere. While these chemical signatures raise hopes of a vibrant biosphere, scientists remain cautious. Extreme temperatures and crushing pressures could just as easily create a boiling inferno rather than a peaceful haven. Kepler 452b, an ancient twin. Kepler 452b, Earth's so-called twin, has spent approximately 6 billion years within the habitable zone of its star. This extended window offers ample time for life to arise and potentially evolve intelligence. Yet its greater mass may result in gravity nearly twice that of Earth, turning even simple movement into a strenuous challenge. TRAPPIST-1, an apartment complex of worlds. Farther away lies the TRAPPIST-1 system, where 7 rocky planets cluster tightly around a red dwarf star. At least 3 orbit within the habitable zone. Each world holds its own promise and its own peril. Locked in tidal embrace with their star, these planets face eternal day on one side and endless night on the other. Technical barriers and desperate distances. Though we have identified promising destinations, the universe confronts us with a brutal truth. Distance. The time trap. Proxima Centauri b, our nearest candidate, lies 4.2 light-years away. At the speed of our fastest spacecraft, the journey would take between 100,000 and 165,000 years, far longer than any human civilization has yet endured. The energy challenge. Escaping Earth already demands immense energy. Crossing interstellar space requires orders of magnitude more. By the Kardashev scale, humanity remains a Type 0 civilization, still struggling to harness even the full potential of its home planet. The limits of observation. We cannot yet see these planets directly. Instead, we infer their presence from dimming starlight or subtle stellar wobbles. To image continents on distant worlds would require telescopes of unimaginable scale, technologies that remain, for now, on the drawing board. Survival risks and harsh differences. Even reaching another world would not guarantee survival. Invisible killers, radiation and vacuum. Beyond Earth's magnetic shield, high-energy cosmic rays would relentlessly damage cells and DNA. Even a slight loss of pressure could cause bodily fluids to boil, a phenomenon known as ebulism. Gravity, friend and foe. Extended exposure to microgravity weakens muscles and bones. Yet on super-Earths, excessive gravity would strain the heart, making every movement, every breath, a struggle. The red dwarf problem. Most habitable zone planets orbit red dwarf stars, violent, unstable suns that unleash powerful ultraviolet flares capable of stripping atmospheres in moments. Reverse contamination. Perhaps most unsettling is the risk few consider. In finding alien life, we may also bring it home. Our immune systems, refined over 4 billion years on Earth, could be utterly defenseless against organisms governed by unfamiliar biochemical rules. The Fermi paradox and the Great Silence. This is perhaps the most unsettling question in the entire game of cosmic hide-and-seek. If the universe offers trillions upon trillions of opportunities for life, then where is everyone? One haunting idea is known as the Great Filter. It suggests that somewhere along the long evolutionary road, from lifeless matter to a civilization capable of crossing the stars, there exists an invisible barrier. Most species, it argues, never pass it. They extinguish themselves just as they approach technological maturity, undone by nuclear weapons, runaway climate change, or artificial intelligence they can no longer control. Even more chilling is the dark forest theory. In this view, the universe is an ancient and silent jungle. Every civilization is a cautious hunter, hiding in the shadows. To reveal one's position, through a radio signal or an interstellar probe, is to invite annihilation. In such a cosmos, silence is not emptiness, but survival. The nature of the search, a quiet trade-off, and so, night travelers, we must accept that the search for life beyond Earth is not merely a scientific endeavor. It is a search for ourselves. Arthur C. Clarke captured this perfectly when he said that there are only two possibilities. Either we are alone in the universe, or we are not, and both are equally terrifying. We live in a world where our own minds gently deceive us about time. Because of neural delay, we experience reality about 100 milliseconds after it occurs. And when we look at the stars, we are not seeing the present at all, but echoes of the distant past. Light takes time to travel. If we were to receive a simple greeting from the Andromeda Galaxy tonight, the civilization that sent it may have disappeared 2.5 million years ago. Night travelers, our journey through the challenges of this galactic game of hide-and-seek comes to a close here. You have seen humanity's quiet perseverance, how we use thought and curiosity to peer into the darkness, searching for companions we may never meet. The universe is vast, indifferent, and often dangerous, yet we remain an inseparable part of it. The atoms within your body were once forged in the heart of a star. Long after we are gone, they will continue their endless voyage through space and time. Now, allow all this knowledge to settle around you like a gentle blanket. Do not worry about great filters or distances measured in millions of light years. Tonight, you are safe beneath your familiar sky. Let the inner fire fade. Let your eyelids grow heavy. Let each breath slow and soften into the stillness of the night. The universe is a vast book, filled with billions of blank pages. We may be only a single sentence near the beginning, but that sentence is where all wonder begins. Sleep well, night travelers.